Hi everyone, welcome back to Dragonfly Engineering. So this week we have a customer's mold that we are going to machine, and this is a mold that they designed, so I'm basically just fabricating to their spec. They sent a 3D model over email. And this mold is an insert mold, so the molding machine is actually a vertical molding machine, and an operator will, so this is the bottom half of the mold, by the way. We'll operate the mold by inserting a soldered electrical component with a couple of wires that fit into these wire grooves. And then in the molding machine, it's going to be a vertical molding machine as opposed to a horizontal molding machine, which is typically what I operate. Well, in a vertical molding machine, gravity is pointing down, and that basically keeps your parts that you're going to overmold in your mold itself, so that you can then place it and not have to somehow tape it on or whatever. But these parts will lay into these three cavities, electrical components, and then the top half of the mold, the top half of the mold in the horizontal molding machine will bring this half down, and it will clamp on, and then inject plastic from this port here. A side port or a parting line port. And this is kind of typical for insert molding, or also benchtop molding machines do this a lot. A guy, John SL, who has a YouTube channel as well, he makes a lot of these style molds for a benchtop molding machine. So now we're making one for a customer as well. Apparently they bought a probably manual molding machine, and now they're eager to try it out with their first mold that I made for them. So, hope you enjoy the probably mostly time-lapsed video of the machining of this custom mold for a customer. And thanks for watching. Right, so we've completed our machining operations and I pressed the bearings in. Also, since we're talking about our guide pins here, it's good to know that these guide pins are actually undersized at the top. So if you buy guide pins and bushings for your mold from a mold supply company, what happens is they grind the top of this pin to be 499 thousandths, even though they say that it's a 1/2 inch guide pin. They actually grind in a taper. To be more specific, there's actually a subtle step in this diameter. So down in the mold where you press this pin into your mold block, the diameter is 0.500 inches, but up here at the top it's 0.499 inches. And similarly with the bushing that you press in the other side of your mold, the lead-in diameter is probably 0.501 inches, or 1/1000th oversized. And then down inside of this bushing, like halfway down, it steps down to 0.500 inches. But you should also keep in mind that one of these, or both of these pins in bushing, when I say 0.500, there's actually a few 10,000ths or so, 0.4. Yeah, so this one, what I say 0.5 was actually going to be 0.49997 would be the actual close diameter on this pin. And then on the bushing over here, it would be 0.5002. So just a very slight clearance, because you can't fit a 1 inch or a 1/2 inch pin into a 1/2 inch hole. You need a few microns on each side to clear. So we can demonstrate how these fit together. So hopefully that made sense, that there's clearance at the lead-in for the bushing and the pin of approximately 1/1000th. So we'll flip this over. I'll make sure that we're in frame. And at the top, you can feel in here a lot of slop. And then as the pin drops down, the pin will engage with the actual true dimension of the bushing, the 0.5001 inches. And now it's starting to lock up better. And then you'll be able to hear the actual ground surfaces, the precision ground surfaces riding on each other. And at this point, there's absolutely zero play between it, or within a few 10,000ths of an inch, or 0.0001. And that way you get a precision alignment, but you're not binding your pin and your bushings, because you do need to have a little bit of clearance. And here at the bottom, it acts like a single block of metal. But when we pull it out, up here, there's slop. You can still bind up your bearings though. But anyway, we can pull it out easily and drop it back on. And it'll engage with high precision. So, keep that in mind. It's best to buy your pins and bushings from a mold supply company, because they give you a little bit of a cheat on the lead in and lead out of your alignment of pin and bushing. So now what we're going to do, I'm going to do a final little polish. Again, I'm looking at the camera, of our surfaces for this pocket. Autofocus. And I'm just going to rub this polishing paste, which I think is particulate of cerium oxide, which is kind of a medium soft mineral or ceramic. And yeah, what we're doing is we're just polishing some of the mill marks from the 1/16 finished end mill out of the mold cavity itself, just so it gives more of a mirror finish and looks better for the plastic parts that are going to be molded. So this is a insert mold. So 2 wires and some electrical component will be encapsulated in this mold with plastic. So that's why we've got the little wire ports here. So some electrical component with 2 wires drops in here. Then they close the mold, and then they squirt plastic in, and then they pull the wire, the overmolded electrical component out of this mold. What exactly it is that it does, I don't really know, but yeah, we're just making this to the customer spec. My paste is pretty much separated. It sat on the shelf for too long. We'll give it a good scrubbing here. Yeah, when you machine aluminum, you always see like a swirl mark from the end mill. And sometimes it's only just a micron or so thick, or the witness or the cut marks are only like a micron or so. So you can usually just rub it out with one of these polishing compounds. That looks pretty good. There's not a critical finish spec on this mold, so I'm not going to worry too much about it. There we go. And these are just Q-tip, bathroom accessories with the cardboard shaft. You can use the wood-tipped ones as well, but pretty much get the same effect. You don't want something that's going to gouge or scratch the aluminum surface, but you just want the polishing compound, which is basically the cerium oxide and probably other grits as well, like micro grits like aluminum oxide, mixed with some sort of pasty carrier to keep the grit on the surface that you're polishing. All right, and then I'll clean this off, and I think we will be done. And we are done. So hope you guys enjoyed the kind of the abbreviated process of making a insert mold for a horizontal molding machine or a vertical molding machine, and everything worked out good. So it comes apart, goes together pretty easily, and then these tabs on the sides probably clamp into the 2 halves of the vertical molding machine so that they can load parts and unload parts after it injects from the front. So thanks for watching Dragonfly Engineering, and we'll see you next week with our next project. Thanks for watching. Goodbye.